Alright, welcome back. So in this video we are going to talk about finding the areas between curves, and specifically we're going to talk about how to do this using integrals. So in the past we've talked about how to find the area under a curve, so between the horizontal axis and a function, but now we want to talk about how to find the area between two curves. So let me draw you a graph of what I'm talking about. So let's say we have some function f of x, it comes down like this, and then we have another function g of x, maybe it comes up this way. And let's look on some interval a to b, as we do. And I want to find this area in between the two curves on this interval. So I'll highlight it here. We're looking for this area in between the curves. And we want to figure out how to develop an equation, a formula to solve, a formula to follow in order to find this area. Okay, so I'm going to think of this broken up into two pieces. So first I'm going to just copy this and look at it, the one piece I want to start with. So what I want to do first is look at something we know. So we know how to find the area under the graph of f. So if I look at this area under the graph of f, I can find an equation for that area. That's just the integral from a to b of f of x dx. So that finds me the area under the graph of f of x. And so then we're going to repeat this because at this point we've now found this entire area. We've found too much area. We want to take off this bottom portion that gives us then just the smaller area we're looking for. So our goal here is to look at the big area under the graph of f and then take off this little area that we've overcounted. So let's repeat this with finding that little area. So if I now look at the area under the graph of g, that area here under the graph of g is exactly the area I'm trying to get rid of. And so I can take the integral from a to b of g of x dx, and that's going to remove that little piece of area that I wanted to get rid of. So in order to find our big area, we are going to take the integral from a to b of f. So that's the first graph we drew with that whole area. And then we're going to subtract off the area under g. And that's the second thing I drew. So we're taking the area under f and subtracting the area under g, and that's going to give us this area that we wanted. And so with integrals and properties of integrals, these have the same bounds on them, so I'm going to combine them together, and I get the integral from a to b of f minus g dx. And this is going to be my formula for the area between those two curves. Okay, so we have another way that we can think about this process. So I'm going to repeat this just with a slightly different process. Let's go ahead and try that. So we have another way to think about this. And let me show you the picture that we had from before. Let's copy that and paste it down here. And so instead of looking at areas here, we're going to go back to our concepts of Riemann sums and finding the areas of rectangles. So rather than, I guess, doing the definite integral right away to find that area, we are going to use some rectangles. If only I could draw one. Let's see if I can make it work. Okay, So let's look at this little rectangle, and we're going to imagine adding up all these rectangles. So this rectangle fills in the space between F and G. And the idea is we're going to find the areas of these rectangles and add them up. So we're going to look at the area of rectangles. So on my rectangle here, we're taking a tiny little change in x, a dx, since we're going from one x location to one just over by a little bit. And then the height of my rectangle is going to be the top value. So on our function, it's f. So you can see up here, it's f. And then we subtract the bottom value, which is g. So we're just finding the total height. We look at the top minus the bottom, and that gives us that length there. So our height is f minus g. Then each of our rectangles will have an area of the length times the width, or of the width times the height, that dx times the height. So each rectangle has an area of height times width. And for us, that looks like f of x minus g of x, that's the height, times dx, that's the width. And so what we're going to do is add up all of these little rectangles, and we're making them infinitely narrow. So we have these little itty bitty narrow rectangles, and we're adding them up. We're setting the width to 0. And so we're going to use an integral for this. This is how we add an infinite sum of areas. So we're going to use an integral for an infinite sum of areas. So remember, we're just adding up all of the areas of those rectangles. And the way we do this is we go from A to B. That's where we're spanning our rectangles between. And we have the height, f minus g, times the width, dx. And this is how we find that area between the two curves. So this looks the same as what we had before when we were doing the areas of f and g and subtracting them. This is just another way to think about it that I think is nice to have both understandings. Okay, so something to point out here is that on our graph, it mattered which function was above or below. So you can envision that if I was looking at the second half of the graph, where the functions cross each other, suddenly the top function would be g and the bottom function would be f, and so our height would be g minus f on this portion. So it really matters which function is on the top and which function is on the bottom. Let me write that out. So as a note, it matters which function is above and which function is below. So when we do problems involving finding the area between curves, we'll just need to make sure we figure out which function is above and which function is below. Okay, so those are the formulas the one formula that we're going to use to find the area between the curves f and g on an interval a to b. And I'll show you some examples in the other videos. This is our main topic for this week, and so we're just looking at this in different ways, and the problems can get increasingly complex, but it all comes back to this basic concept of finding the area between the curves. Thanks so much for watching, and I will talk to you in the next one.